Hello, in this video I'm going to talk about extension methods in C#. Extension methods are a way of adding new functions to existing objects without modifying the original object. You can add new functions onto an existing object even if that thing is in a library and you don't have access to the source code. Also, it seems to be a standard interview question, so I would know how to answer the question, what is an extension method? And before we get into extension methods, though, let's talk about some background. And you may have seen the this pointer. Sometimes when you're working in a function and maybe you have a name collision between a parameter and an instance variable, you have to use the this pointer to specify whether you mean the parameter or the one that belongs to the class. Like, where does this pointer come from? Why does it work? How does it work under the hood? How is it just sort of magically there? So let's talk about the this pointer, because when we write extension methods, we're going to have to explicitly write our own this pointer. So let's imagine we had a class called A, it has an instance variable called V, and it's got a public function here. I forgot to put the word public on there, but imagine this is public, called do something. And all it does is add the parameter to the instance variable and return it. So that's all it does. This is what it gets turned into under the hood. The compiler generates a function that takes a secret first parameter, and that first parameter is a reference to the object to modify. And anywhere in that function where you are modifying an instance variable, the compiler sneaks in this dot or this arrow in C++. So there's a hidden first parameter in all instance methods, and anytime you try to access a member of the object, that access occurs through the this pointer. So we have to know this because when we write extension methods, we explicitly add the this pointer ourselves. All right, so let's imagine that we've created a new object of type A, and we're going to call A's do something function. What does this get turned into by the compiler? Well, the compiler generates a class, generates a function, and you can see here that the object that is being modified, A, is actually snuck in here as the first parameter, and that's how whatever goes on inside of this do something function applies to object A and not some other instance of that class. So that is what happens. The dot notation gets rewritten as this, where the object is passed in as the first parameter. So the object that this applies to, or the object to be modified, is passed in as that first parameter there. That becomes the this pointer. Static functions don't have a this pointer, and that's why they can't operate on instance variables. It doesn't make sense, right? Static functions can only operate on static variables and parameters, right? Static functions cannot operate on instance variables because there is no this pointer in a static function. All right, so let's get back to extension methods. What are extension methods? Extension methods are a way of bolting new functions or retrofitting new functions onto existing classes without using inheritance or modifying the original source code in any way. So, I mean, one way we could hypothetically add a function to an object would be to subclass it and provide a new function. That is one way of doing it, but then we don't really have the original type anymore. We've got this new type. It's not a perfect solution. So in this example, we have a class called A. It has function 1. Let's say we need to add another function to it that will make our lives easier. We can't, let's say A is in a library here. It's already been compiled. We don't have access to it. We could make a new class called B that inherits A and put a function in there. And we could have a list of B objects and treat them like they're class A's, because a B is an A. According to the rules of inheritance, just like kind of a cat. Cats and dogs are all mammals. But that's really kind of a kludge. It doesn't work that well. There's a more elegant way, and that's using extension methods. Let's talk about extension methods and how we can add a new function onto an existing object. So extension methods have a few restrictions on them, or there's a kind of a pattern that you have to follow when you write an extension method. Extension methods have to be static. Static methods don't have a this pointer, but we explicitly write the this pointer ourselves. Extension methods have to go inside of a static class. Static classes are just where you put libraries of functions. So the math class is static, and all it has in it is static functions and some static variables. And that static function that we're going to add to an existing object has to have a this pointer, and we'll look at what that actually looks like in an example. But those are the three things you need for an extension method. The extension method itself has to be static. It has to go in a class that's static, and that function has to have a first parameter that is a this pointer. This is a special word in C#. Okay, so and if you're wondering why it has to go in a static function, a static class, static classes are just where you put libraries of functions. That's just a restriction on the way extension methods are. You just have to put them in a static class. Okay, so as I said before, extension methods have a first parameter, which is a reference to the object to modify. Before the reference to the object, there's a special keyword that you put in, and that is this. We actually put the word this right before the parameter in the function declaration, and you'll see an example of that coming up here. So let's say that we've got a class called A, and it has function 1, and it says like in function 1. Let's go see what it would take to make to put an extension method on class A. So I'm going to make a static class here, and it says extend A. So I've got a static class, and inside of extend A, I have a static function. So function 2 is static, and notice here it takes the first parameter is a reference to an object, right? This is the object to modify, and see how we have the word this here? This is a keyword here that tells the compiler, all right, this thing is an extension method, and when you see it being called, pass in the object that's being modified as the this pointer. And then that's it. Now the cool thing here is in order to call this function, you could call it on any object of type A. You never ever have to type extend A. You could say a.function2, and this function will get called, even though the original class does not have a function 2. This extension method here gets bolted onto class A. So what we've done is we've kind of retrofitted a new function onto an existing object. Just by having a static class with a static function in it, and that static function has a this pointer. That this pointer indicates, or is kind of a symbol that this thing is an extension method. All right, so there we go. Note that those class and the function are both static. Note that we have a this pointer. And here's an example of how we would call that. We make a thing called A, and we're calling it thing, and then we can call thing.function2. So it's like, where did this function 2 come from? Well, it was in the class that we wrote, where we put our extension method. It's like we've magically added function 2 onto our thing, right? So thing didn't originally have a function 2, but by creating this extension method, now it does have a function 2, right? So that's an example of how you create the extension method and then how you call it. It's like that function has always and forever been there. And somebody using that function 2 would not necessarily know that it's an extension method, and it will even show up in the IntelliSense. If you type thing dot, you will see function 1 and function 2 both listed as functions that you can call. C# added extension methods back in 2007, and it was because of they were needed to support LINQ. LINQ is a type of SQL-like query language, a database query language that's built right into the language, and all of the LINQ operations are actually implemented as extension methods, and we'll get more into that when we get to LINQ. So that's what an extension method is right there. So let me make a quick example here and just show you one in action. I'm going to make a new project, add new project. I'll make a console app here, and I'll call it like, extension demo or something, extension demo. And let me come down here, and I'll make a class that extends the integer, static class, and I'll call it int extensions. So this is where I'll put extensions to the integer class. So extension methods have to go in a static function, and then those extension methods themselves have to be static. So I'll make public static, and I'll make a function called square that will return an integer. So what I'm going to do is bolt a function onto an integer called square, so I can just say, hey, square me, and now it'll return the integer multiplied by itself. So what does this extension method take as its first parameter? It takes a this pointer, right? So there's the word this. That indicates that this is an extension method, not a regular instance method. And I have to specify the type of object being modified. And now I have to give my parameter a name. I could call it self or something. I could call it, I for int. It doesn't really matter what you call it. So then what I can do is just say return self times self. Excuse me. There you go. So now what I have done here is I have created an extension method on an integer. So now integers, the integer class now has a square function. So up here in my main function, I can say console.writeLine, enter a number to square, and then let me read in a number here. So I'll say int x equals convert dot to int32 console.readline. And obviously if somebody types in a letter, that's going to blow up with a bad number format exception, but we'll assume that people are being nice and playing by the rules in this example. And now what I can do is I can say console dot writeLine. Okay, so what'll I do here? Squared is, I don't need the carriage return. All right, so what am I going to put in for my parameters here? I'm going to say x squared is, now watch this, x dot. Now you can see square is a function. It's like the square function that I just created here is now part of the integer class. It's like I've bolted that function, retrofitted that function into the integer. And now I can, it's like that has always been there. It's like that, it's no different from if that function had been built into the integer class from day one. And then let me just hold the console open here, console.read key, read key, there we go. All right, so let's run this and see what it does. I'm going to put a breakpoint here. Let's run, oh, wrong program. As always, I've got the wrong project selected. Set a startup project. Here we go. Let's run that. And, okay, console, enter a number to square. Put a breakpoint on the next line and run. And where's our console window? There we go. Enter a number to square. So I'm going to type in 20. Why can't I? I'm going to have to remove my breakpoint. All right, so 20. Why can't I type in numbers? Ah, so aggravating. Let me run that. Oh, great, wonderful. All right, apologies. So I'll put in, enter a number to square, and I'll type in 20, hit enter. Okay, so now you can see, let me hit F11, and it should step down into the square function. So you can see now I'm actually in the extension method, and this pointer is referring to 20. This is referring to the object to modify, and I return self times self, and now it should have printed out 20 squared is 400, right? So there's how to make an extension method. It's very cool. You can just add a new function onto an existing object. Like, let's say you've got a list of integers. You can make an extension method for a list of integers and put a sum function on there, so it returns the sum of all the integers in the list. You could do something real cool like that. Or you could put an average, put an average function on a list of integers, and now if you call the average function, it'll sum up all the integers and divide by the count and give you the average. So there you go. Extensions are just a way of bolting a new function onto an existing object, and the way you do that is you create a static class that has a static method, and that static method has a this pointer to the object of the type to modify. So there you go. That's how you create an extension method. Be sure you know about extension methods. That seems to be a standard interview question. So if you have any questions about that, just feel free to ask. I'll be happy to help.